Welcome back to Science Mathematics. In today's video, we are going to see an extract of the Northwest Regional Mock 2021 question in Mathematics Paper 2, question number 10. Now, the Roman one says a relation R is defined on the set of integers by A is in relation with B if and only if A squared plus B squared is equal to A plus B all squared minus 2AB. Now, we have to show that R is symmetric. So, let's prove. Now, R is symmetric. R is symmetric if only if for every A, B that will belong to a set of integers, then every A, B that will belong to the set of integers, if A is in relation with B, then B should be in relation with A. Now, A in relation with B, so it means you are going to leave from here in order for us to reach the conclusion. Now, but we know that A in relation with B is if only if A squared plus B squared is equal to A plus B all squared minus 2AB. Now let's show that B is in relation with A. So it's quite a simple task. Now all we have to know here is we have to know some properties of addition and multiplication in the set of integers. Now in the set of integers, addition is commutative, that is A plus B is equal to B plus A. So we can take any integer, any two integers of your choice, any positive or negative whole number. So if you take negative 3 plus 2, it should be the same as 2 minus 3, so negative will equal negative 1. Likewise with the product, negative 2 times 3 should be equal to 3 times negative 2, and this will give negative 6 equal negative 6. So in the set of integers, addition and multiplication are commutative, and so we can use that particular property here. So since addition and multiplication is commutative in Z, then we have that we can interchange this. So that statement will be if only if we have B squared plus A squared to be equal to B plus A all squared minus 2BA. So this now shows that B is in relation with A. Since B in relation with A simply means wherever you see this A, you simply replace by B. So we have shown clearly that B is in relation with A, and hence now this is since B, so you can say where B is in relation with A. Since B is in relation with A, or let's conclude since A is in relation with B implies that B is in relation with A, then R is symmetric. Then R is symmetric. Now we pass on to the next question. Okay, so let's pass to the Roman 2 question. So here we have question on matrices, Roman 2, to find the inverse of this matrix. So I'm going to let M to be my matrix 2, negative 3, 2, 1, 4, negative 1, 5, 2, 1. Now to find the inverse, there are several methods which you can use. So I'm going to pass through the algebraic method, which is familiar to many. Now the first thing we are going to do is to calculate the determinant of our matrix. Now the determinant of the matrix, be very careful each time you are calculating this particular value, because any slight mistake, it's already an error in your inverse. So we are going to use the shielding methods to calculate the determinant. Others can decide to use the Cramer's rules or the Saros method. So in order for us to get the determinant, we are going to do some blockages. So I will block this, and I have an equivalent 2 by 2 matrix. Now this coefficient is written down, so I have 2 times the determinant of 4, negative 1, 2, 1, now minus, since I'm going to use the sign convention of matrices, so this is plus minus plus, so I have minus, the next number is negative 3, so we do the same block, so we block, so I have this, we block the respective row and column to which it belongs, so we block, and the equivalent 2 by 2 matrix is 1, negative 1, 5, 1, then plus, that's the next sign, 2 times, we get the next block, and you block, so we have 1, 4, 5, 2, 1, 4, 5, 2. Now that's the simplest form. Now this implies that the determinant of our matrix will be equal to 2 times, you can calculate the determinant of a 2 by 2 matrix, which is AD minus BC. So the product of the leading diagonal, which is 4 times 1 minus 2 times negative 1 minus, so minus 3 will give plus 3 into 1 minus negative 5 plus 2 into 2 minus 20. So this will give 4 times 1 is 4, 2 times 4, that will be 4 plus 2, that will be 6 here, plus 3 into 6 plus 2 into negative 18. So this will give 12 plus 18 minus 36. Now 12 plus 18 is 30 minus 36, and so this will give negative 6 as the determinant of our matrix. Okay, now the next step in doing this, in finding the inverse using the adjugate method, is we obtain the transpose of our matrix M. So the transpose is simply obtained by interchanging row and column. So our row will become our column. So we have row 1, that's 2 negative 3, 2 will become our column. So we'll now write it as 2 negative 3, 2. The next entry, that's row 2, will now become our column 2, 1, 4, negative 1. And row 3 will become our next, that's 5, 2, 1. So that is transpose of the matrix. Now immediately after getting this, we are going to find the adjugate of the matrix M. Now to find the adjugate, we are simply going to obtain the cofactors of this matrix. Now here we are going to use the sign matrix. So notice this is a sign matrix. So the sign matrix, we have plus, minus, plus, minus, plus, minus, plus, minus, plus. Now we are going to use this in order for us to determine the adjoint of this matrix. Now the difference between this and determinant is that we don't take into consideration the elements which we are blocking. Now to calculate the adjugate, we are going to begin by getting the cofactors of 2. Now we shield, as we shielded at the level of the determinant, taking into consideration the sign matrix. Now here we have this is our equivalent 2 by 2 matrix, so we obtain its determinant. So we are going to have 4 times 1 minus 2 times negative 1. So we have a 4 times 1 minus 2 times negative 1, and this will give us 6. Now that 6, we realize that the sign of the first entry is positive, so it's going to maintain its sign. So the first entry is 6. Now for the second entry, we do same. For the second entry, we shield, and we have negative 3, 2, 2, 1. So the determinant, we are going to have 1 times negative 3 minus 2 times 2. 1 times negative 3 is negative 3 minus 4, and this will give negative 7. But because of the sign, the position of the entry and the sign, we see that this is negative, and here we have a negative 7. So the negative will be dealt with, and so here we are going to have a positive entry. So always multiply your final results with the position of the sign from the sign matrix. Now the next is we have 5, 1. So we shield 5. We have negative 3 times negative 1, that will give 3, minus 4 times 2, which is 8. So the final result will be negative 5. Sign matrix positive, so negative times positive, negative. So here we have a negative 5. Okay, next we shield 3, the row and column to which it belongs. So we have 1 times 1 here, which is 1, minus negative 1 times 5, so that will be plus 5. So we have 6, but sign negative 6. And the next is we do that for all the elements. Next is 4, shield 1 times 2 is 2, minus 10, that will be negative 8. Negative 8, sign positive, so it remains negative 8. We do same for 2, we shield. We have negative 1 times 2, that's negative 2, minus 2, negative 4, sign negative, so it becomes positive 4. We do same here. 2 times 1 is 2, minus 20, negative 18. Now negative 18, sign positive, so it remains negative 18. And for the last two elements, we shield. We have 2 times 2, which is 4, minus negative 3 times 5. And this gives 15 plus 4, which is 19, sign negative. So here we have negative 19. And lastly, now for the last, we have this 4 times 2, that will be 8, minus 3, that will be 11, sign positive. Okay, now let's take the inverse of our matrix. So M inverse, it's 1 divided by the determinant of M, all of these times the adjoint. So therefore the inverse of our matrix will be equal to 1, our determinant was negative 6, times our adjoint, which is 6, 7, negative 5, negative 6, negative 8, 4, negative 18, negative 19, 11. Now, in order for you to verify if your inverse is correct, you can always use the property that the matrix times its inverse, or the inverse times its matrix equal to I, where M is a square matrix. So you can verify that is you take your matrix just on a rough sheet of paper. So you have 2, negative 32, that's 2, negative 32, 1, 4, negative 1, 5, 2, 1. So 1, 4, negative 1, 5, 2, 1. So we multiply this by the inverse. I will keep the factor of negative 1 and 6 outside. So here we have 6, 7, negative 5, negative 6, negative 8, 4, negative 18, negative 19, 11. Okay, so let's do this multiplication. So we have negative 1 and 6. Multiplication follows the order row by column. So the row in the first matrix multiplies the column in the second. So we have 2 times 6. 2 times 6, that will be 12. Negative 3 times negative 6, that will be positive 18. And this will be 2 times negative 18, that will be negative 36. So 12 plus 18 is 30, minus 36, we have negative 6. That's the first entry. Now do the same for the others. Row 1, column 2. Now to do that, we have 2 times 7, which is 14. Negative 3 times 8 will give plus 24. And 2 times negative 19 will give negative 38. Now 14 plus 24 will give 38 minus 38, which is 0. We do same for the others. The same row goes with the third column in the second matrix. So we have 2 times 5, which is negative 10. Negative 3 times 4 gives minus 12. And 2 times 11 gives 22. So at the end we have negative 22 plus 22, which is 0. Now we go down to row 2, column 1. So we have 1 times 6, which is 6, plus 4 times negative 6, which is negative 24. 18 times negative 1 times negative 18 gives positive 18, and this will give negative 18 plus 18, which is 0. Now the next entry is row 2, column 2. So we have 1 times 7, which is 7. 7 times 4 is negative 4 times negative 8, sorry, will give us negative 32. And negative 1 times 19 will give plus 19. Now 7 minus 22 will give negative 25 plus 19, and this will give negative 6. Now next we have row 2, column 3. Now 1 times negative 5, so we are doing this. 1 times negative 5, we have negative 5 plus 16 minus 11. So this is 11 minus 11, which is 0. Now the next is we have row 3. Okay, so for row 3, so we have 5 times 6, that will be 30, minus 12 minus 36. Let's verify something. It's 521, 521. Okay, it's 521 here, so it'll be minus 18. So this will be 18 minus 18, which is 0. It does not affect any of our results since we're multiplying with the first two. Okay, so the other will be 5 times 7, which is 35. 2 times negative 8 is minus 16. And 1 times negative 19 is minus 19. So if we remove 16 from 35, we are left with 19 minus 19. So the final result is 0. Now the next and the last is this times the last column. So we have 5 times 5 times negative 5 will give us negative 25. 2 times 4 plus 8. 1 times 11 is 11. Now 25 minus 8 will give us negative 17 plus 11, and this will be negative 6. Okay, well, we simplify this. If I multiply also by 1 on 6, we have negative 1 on 6 times 6 will be 1, times 0 will be 0, 0, 0, 1, 0, 0, 0, 1. So we see that it gives us exactly the identity matrix. So that's how you do to verify if your inverse is correct. So that's why you have to take much time to compute your inverse. You don't rush while computing the inverse, because doing the slightest mistake will cost you all your marks. So let's proceed with the next part of the question. Okay, now the next part is about, so we have our inverse already, so we have verified the property. So that's just an extra. You don't do that on your script. Okay, now we go to the next, which says we should hence solve the system of equations 2x minus 3y plus 2z equal to 2, x plus 4y minus z equal to negative 4, and 5x plus 2y plus z equal to negative 2. So we'll write that down. So let's get it here. So we have 2x minus 3y plus 2z is equal to 2. Then here we have x plus 4y minus z is equal to minus 4. And here we have 5x plus 2y plus z is equal to minus 2. Now what we realize is all the coefficients of x, y and z in all the three respective equations simply gives us the respective entry of our matrix M. So for example, the coefficient of x is 2, here we have 2. Coefficient of y is negative 3, here we have negative 3, 2, 2. The equation of x 1, 1, 4, 4, negative 1, 1 and so on and so forth. Now this means that we can write this particular system of equation in a matrix system, that is in the form M times x will be equal to a certain n, where our n will be the column matrix on the right hand side. So this means the respective entries, so we write down the coefficients. So here we have 2, negative 3, 2. Here we have 1, 4, negative 1, 5, 2, 1. Now this multiplies our variables, that's x, y, z, that's the column matrix, and this will be equal to 2, negative 4, negative 2. Okay, now we have to solve for x. So what we do is, in order to remove this, we are going to pre-multiply by the inverse. So if we pre-multiply by M inverse, this is what we'll have. I'm not going to write it as huge as that, so I'm going to use this to explain. So if we pre-multiply, it means that it comes in front. That's the meaning of pre-multiplication. So it means we have M inverse times M times x. This will be equal to M inverse times n. But notice this is the same as M inverse times M, all of that times x, which will be equal to M inverse times n. But M inverse times n, we saw that it gives the identity matrix times x, which is equal to M inverse times n. And the identity matrix times any matrix is that matrix x, it will be equal to M inverse times n. So we are going to use that property. So this implies that since our x is the column matrix xyz, so we have xyz simply be equal to M inverse, which is 1 on negative 6, or let me just say negative 1 on 6, all of that times 6, 7, negative 5, 6, 7, negative 5, negative 6, negative 8, 4, negative 6, negative 8, 4, and lastly we have negative 18, negative 9, 11, negative 19, 11, negative 18, negative 19, 11. So this multiplies our column matrix on the right hand side, which is 2, negative 4, negative 2. Now what is the order of this matrix? This is a 3 by 3 matrix, and the order is a 3 by 1 matrix. So since these numbers are the same, it is compatible for multiplication. So here we can multiply those matrices. So I'll have negative 1 on 6 multiply following the order or by column. So the multiplication will be simple. So here we have 6 times 2, which is 12, plus 7 times negative 4, which is minus 28, plus negative 5 times 2, which is plus 10. Now 12 plus 10 is 22. 22 minus 28 will give negative 6. So our first entry is negative 6. The next, we now take O2 column 1. So we have negative 6 times 12 times 2, which is negative 12, plus negative 8 times 4, which is plus 32, and we have 4 times negative 2, which is minus 8. Now negative 12 minus 8 is negative 20, so we have 32 minus 20, and our result will be 12. And the last, negative 18 times negative 2 gives negative 36. We have 19 times 4, that will give us 19, that's negative 19 times negative 4, which is 19 times 4. 9 times 4 is 36. We have 6 and carry 3, so that will be 76. Plus 11 times 2, that will be minus 22. Now we have minus 36 minus 22. We have 58, and now we have 76 minus 58. Here we have 8, and here we have 1. So the result is 18. Okay. So on there, we have evaluated the product of the matrix. So this therefore means I write this like this. So here we have x, y, z. So therefore, all this implies, let's simplify, that depends, is x, y, z is equal to negative 1 on 6 times negative 6 is 1. Negative 1 on 6 times 12 is negative 2. Negative 1 on 6 times 18 is negative 3. Now from equality of matrix will imply that x will be equal to 1, y equal negative 2, and z is equal to negative 3. So this is the solution to the system of simultaneous linear equations 1, negative 2, negative 3. You can always verify your value by plugging them inside. So we have 2 times negative 1 minus 2 times 1 times 2 times negative 2, minus 3 times negative 2 plus 2 times negative 3. Does it give us 2? Questions. So where you have 2 plus 6 minus 6, result 2. So it works for the system of equations. You can verify for the second and third etc, but at the end their results should be consistent. So this brings us to the end of this video. Please do not forget to like, share and subscribe. See you in our next